Okay, now let's see, sometimes when you are making the graphs or when the MCQs are given and we have to solve the problems in couple of seconds, then by the sight we have to compare the slope, correct? So let's see some of the basic skill for comparison of slope without going in much time wastage. See, whenever we have to positive slope, so this is very simple as we've seen in lecture 1. If you have to positive slope, so higher the slope, higher will be the inclination with this positive x-axis, correct? So say this is M2 and this is M1, both are positive. That's why both the lines are going up. So surely you can say M2 is greater than M1. Got it? So suppose we have to plot this graph, y as a function of x is 3x plus 2 when x is greater than equal to 0 and less than 5, and y is equal to 5x plus 2 when x is greater than or equal to 5. And since we are starting from x is greater than equal to 0, I need not to go on the negative side of the x-axis, and as a rule I'm making a vertical line corresponding to the value of x where the function is changing its behavior, 5. Okay, now what is your segment 1? So you can see segment 1 we have a graph of 3x plus 2, and since this graph will cut the y-axis because you are starting from x is equal to 0, so surely this graph will cut the y-axis. So instead of finding the point, you can find the value of m and c. So m is 3, graph will go upward, and c is coming to be 2, and you can point the end point we have to find because graph will end at x is equal to 5. So when x is equal to 5, y will be equal to how much? 3 into 5 plus 2, so we'll get 15 plus 2, that will be how much? 17. Got it? So you will get a graph, I'm making it say with yellow colored. So 0 is included, and here the intercept is coming to be 2, so it will go from 2 to 17. And again I'm making a very freehand sketch, not up to the scale, and this value is included. I'm making a dark circle 2, and this value is excluded. And here what is the value I'm getting? So here I'm getting the value of y as what? 17. Of course technically 17 will not be included in first segment because 5 is excluded from the domain. Now if you come to the segment 2, so this is applicable when x is greater than equal to 5 and there is no end point, because so the graph will go till infinity, and here y is 5x plus 2. Now if you compare it with 5x plus 2 with mx plus c, so you'll get m is equal to what? 5. And of course c will be 2, but c won't be useful for interception because you know the graph is not going till your y-axis. We are starting from x is equal to 5. So see, first of all, what I was focusing on the comparison of slope. Okay, so let's see where the graph will start. The initial point for segment 2, the starting point, because we have to mark the starting point. So when x is 5, that is the starting point for segment 2. So y will be 5 into 5 plus 2, so we'll get what? 25 plus 2, that is what? 27, correct? So you'll get 27, a value of 27. So graph is discontinuous in nature. Can you see? The graph has no continuity. So if this is 17, I have to make another point, 27. Say I'm making a 27 here, the value of y, and this graph will start at this point, and this point, see, I'm making a dark circle. Can you see here I made a hollow circle because at x is equal to 5, y is not equal to 17. 5 was not included in segment 1. But when x is equal to 5, y will be described by this function, and this is coming to be how much? 27. Now the graph will go upward. Now the question is that, this was all clear, graph will be going upward from this point. Now the question is that how the graph will go. Whether this graph will be parallel, what do you think? Will this graph be parallel to graph 1, or this graph be inclined lesser as compared to graph 1, or this graph be inclined more greater compared to graph 1. So this will be decided by the slope. Both are the graphs are having positive slope, so both are going up. The slope of graph 1 was how much? 3, and the slope of graph 2 is how much? 5. So clearly you can see the slope of 2 is greater than slope of 1. So your second graph will have more inclination with the positive x-axis. So when you are making the second graph, so it won't be parallel to first graph. If this is the first graph, it won't go like this. It will be inclined more. Correct? It would be something like this. And of course, it will be going till infinity. So just for the sake of comparison, if you're doing the comparison, so just for the sake of comparison, if you're making a parallel line to graph 1, if this is a parallel line to graph 1, okay, so your second graph will be inclined more upwards. This is your second segment of the graph with a dark circle, and of course this will be going till infinity. So this is the piecewise graph for this function of y. Both are having positive slope. The graph is discontinuous, there is a discontinuity, and first graph is lesser inclined with the x-axis, second graph is more inclined with the x-axis. Now let's see if both graphs have the negative slope. So in lecture 1 I told you, if the graph has a negative slope, the graph will go downward, and it will, you can say, you can, instead of now seeing the inclination with this positive side, you can see the down inclination. Higher the modulus of f, modulus means absolute value of f, higher this value of f, higher will be this down inclination. Got it? This we have seen in first lecture. Like if I am starting both the graphs from the same point, okay, and say one is minus 4x and one is minus 2x. So of course both the graph will go downward. Now graph 1 is minus 4x. So if you compare it with y is equal to mx, the value of m1 is minus 4, so modulus of m1 is 4, and graph 2 is minus 2x. So here the value of m2 is minus 2. So we have to see the modulus in the negative graph. This is 2. So what do you think? Which graph will be more inclined downward? Of course, that one which will be having higher modulus of m. So this is your graph 1 and this is your graph 2. So this is what? Minus 4x graph, and this is your minus 2x graph. This is having lesser inclination, down inclination, and this is having more down inclination. So when both the slopes are negative, the one with greater modulus value will be inclined more downwards. Okay. Now see, if one slope is positive and one slope is negative, if you are making a two piecewise graph, okay, say one straight line is going up and one straight line is going down, like this. So if you see, this angle will be same as this angle, alternate angle. So say this is alpha and this is beta, this is slope m1 and this is slope m2. Okay, say m1 is positive, of course it will be positive, the angle is acute, that's why the line is going up, and m2 is negative, that's why the line is coming down. Okay, now if you can see, you can apply your intuitive effect. If mod of m1 is equal to mod of m2, if both the slopes have same magnitude, say one has a slope of 3 and one has a slope of minus 3, so you can see that both inclination will be same. Correct? We have same inclination in both the graphs. Same inclination mean this angle and this angle will be same. If this angle is theta, this angle will be theta. Okay? This is when mod of m1 and mod of m2 is same. Okay, and of course when you are making a freehand sketch, so you cannot make the inclination with angle. So what is the way in making the freehand sketch? If you want from the same height, suppose if one graph is like this, okay, and we are having the same height, and this inclination is θ1, and I want to make a graph with lesser inclination, negative side, negative lesser inclination or slope. So you know slope is what? Rise by run. Rise, the height is same, correct? So if you want to decrease the modulus of slope, what do? Just simply stretch the run. The running portion can be stretched for the same height. So in case this is lesser inclined, so we can stretch this portion. So this angle will be θ2. Now surely you can say θ2 is less than θ1. Got it? So this is the way how we will use in freehand sketch. Freehand. Of course we won't be measuring the angles. Okay, so wherever you have a lesser slope for the same height, do what? With respect to the reference graph, stretch the running line, the horizontal line. Okay, so here see what I'm doing. Since both the slope have same magnitude, so I'm keeping these heights equal. Okay, now if you see, mod of m1 is greater than mod of m2, and m1 is positive, m2 is negative. Now what you will get? So I'm making one line, this is m1 positive, and I will apply this scale. So this inclination will be lesser because mod of m2 is less. Let me stretch the x-axis a bit more. So this is the same height, and now I'm stretching the run for the second portion. This is mod of m2 negative, the graph is going down. So in this case, mod of m1 was greater than mod of m2. Now if you have a case, again same thing, like m1 is positive, m2 is negative, and say mod of m1 is less than mod of m2. So m1 is positive, the graph will go upward, correct? And now for the second segment, the slope modulus is more, so it will have greater inclination. And if you are having a greater inclination, what you can do? You can compress the run. You can compress the horizontal distance. So this is your m2 negative, and here mod of m2 is greater than mod of m1. Got it? So this is how you can compare the slope, positive, negative. Positive is line going up, negative is line going down. Lesser slope, lesser inclination. Lesser inclination mean for the same rise, for the same height, greater run. For the same height, greater run. Okay? Now let's see, the velocity of a car moving along the x-axis is defined as 3t meter per second. So we have a model which is describing the motion of the car with the time axis in seconds, and the velocity is given in meter per second, and we have to start from t is equal to 0. We need not to worry about the left side of the graph, and I will make a line at t is equal to 10 second. That is the turning point or changing point of the graph. So I'm making a point here 10. Now see, in the first segment, the velocity is, if you see segment 1, the velocity is 3t, and segment 1 is starting from x is equal to 0. So I can compare it with this. So the slope is coming to be 3 and the intercept is coming to be 0. So a graph will start from the origin and it will go like this. This value is included, t0 is included and t10 is excluded. And what will be the velocity at 10 second? So I can find the end value. Let me put the value of t as 10. When t is equal to 10 second, my velocity will come to be 3 into 10, that will be 30 meter per second, but this is not included in this graph. Okay, Then I have minus 3t plus 60. See. Now for segment 2, I have v is equal to minus 3 plus 60. So again, this is a linear equation. The graph will be a straight line. And if I compare it with the standard equation mt plus c, so the slope is coming to be minus 3 and intercept is coming to be 60. Now it has a negative slope. So in the second segment, the velocity time graph will come downwards, correct? It has a negative slope. So as you move on the time axis, and there is no end point, t is greater than 10 seconds, so the graph will go forever and ever. Let's see the initial point, because intercept will be not of much help. The graph is not cutting the vertical axis. So when t is equal to 10 seconds, let us find what will be the corresponding value of v. Minus 3 into 10 plus 60. So I'll get minus 30 plus 60. So your answer will come to be 30. So when t is equal to 10, it is 30. Number 1, first point. So I'm making a circle here. It is also having a value of 30, and this value will be included in the second segment. Number 1. Number 2, the graph will go down. Number second property, slope is negative. So the graph will go down. And now the third property, in making the freehand sketch, you have to compare the relative inclination. So here the modulus of slope is how much? 3. And in the second segment, the slope is minus 3. So the modulus of slope here is also 3. So can you say, though the second graph will go down, but it will have the same inclination, same steepness. So when, right now we have seen how to make such graph. When it has, say, the same steepness, here the height is same. So we will take the same run. Same run means equidistant. So if this gap is 10, you can take this as 10 and you can write yourself 20 if you want, and you will also cross check, it will come to be 20. So the graph will go forever and forever like this. Can you see here the slope is 3, here the slope is minus. Of course the slope will have a unit here, it will be meter per second square. And you can cross check it. See, I plotted the value of 20 by symmetry, by the logic of same inclination, by the logic of the same modulus of the slope. You can also cross check. It means when t will be 20, we will have to become 0. In this segment, what it is suggesting, if you keep the value of t to be 20, the value of v will come to be 0. Is it coming to be? You can cross check. What is the value of v when t is equal to 20 seconds for second segment? So we have to apply this equation, minus 3 into 20 plus 60. See, you are getting the value of 0. Correct? So you can cross check your value, the value which you marked by the equal inclination. So at 20 seconds the velocity is 0. Before 20 seconds the velocity is positive. After 20 seconds the velocity is negative. Till 10 seconds the velocity is linearly increasing. Can you see from the graph? After 10 seconds the velocity is linearly decreasing. Before 10 seconds the slope is 3 meter per second square. After 10 seconds the slope is minus 3 meter per second square. So many information you can judge from the graph, correct? Now see the second problem. A particle is moving along the x-axis. Again, it's a model of kinematic. A particle is moving along the x-axis and you are given the description of the position of the particle, x as a function of time, in 3 different set of domains, between 0 and 5 seconds, between 5 seconds and 15 seconds, and between 15 seconds and 25 seconds. And we can see all the 3 functions are linear function. 5t 25, that's a constant function, also in the class of a linear function. Minus 2.5t plus 62.5. So all the 3 graphs will be straight line graphs, number 1. Number 2, first I'm making the coordinate system. So vertical axis will be x as a function of time. There is an origin and we need not to go to the negative time because the domain is starting from t is equal to 0. So I'll make the different turning point of the description of the function on the x-axis. So one is the 5 second, okay, and then another is 15. So I will making a freehand sketch. So if 5 is something like this, and then I have to go from 5 to 15, so the gap would be something, double of this. So I can make something like this. So this is your 5, this is your 15, and then I have to go till 25. So this gap is 5, this is 5 to 15, 10, and then again I have to go for a gap of 10. So I'm going for this gap, again a bigger gap, so I have to cover a gap of 10. So this is 25. Okay, now let's see segment 1. Segment 1 is when t is between 0 included 5 seconds, x as a function of t is 5t. So you can see x is equal to what? mt plus c. M is equal to 5 and intercept is 0. So the graph will start from the origin. There is no intercept and this value is included at t is equal to 0. The particle is at the origin. 5 is excluded, so I am making a hollow circle here. Okay, now let's see segment 2. And also let me mark this value. Always we have to mark the end values. Okay, so what is this corresponding value of x when in segment 1? T is equal to 5. So x will be equal to how much? You can say 5 into 5, that is 25 meter. So this is your 25. Of course, I'm writing this in meter. Okay, this is your segment 1. Now if you see segment 2, so in segment 2, x is equal to, as a function of t, is 25 meter. So here the value of x is really independent of the value of t. It is not depending at all on the value of t. So it's a constant function, and so we know the graph will be a straight line at 25, and that hole that was blank now will get filled because this second segment at x is equal to 5 is giving it a value of 25. Okay, so the graph becomes continuous at x is equal to 5. Then we have the third segment between 15 and 25 seconds. Both values are going in this segment. So in the third segment, we have x as a function of t is minus 2.5 t plus 62.5 when t is between 15 and 25, correct? So if you see, let me, first value is what? 15 second. So here I can find x as a function of time. So I'll get minus 2.5 into 15 plus 62.5. So I'll get minus 37.5 plus 62.5. So I'll get it 25 meter. So my graph will start from this point. One thing is sure, this is the initial point and this will be included here 25. Second property which I can see here, if you compare it with x is equal to mt plus c, the standard form of the straight line, the slope is negative, minus 2.5. There is no very much significance of intercept. So the line will go down. Sure, the line will go down. Correct? And you can tell the relative inclination. That line in segment 1 that was going up, segment 1, and this is a segment 3. There the slope was how much? I guess there the slope was 5. Okay? And here the slope is how much? Minus 2.5. So if you see its modulus, it will come to be 5. And if you see its modulus, it will come to be 2.5. So surely you can see modulus of M2 is less than modulus of M1. So M2 will have lesser inclination. Okay, your third segment will have lesser inclination. In this segment, you will have lesser inclination. And what is the freehand or geometrical interpretation of lesser inclination? For the same height, if you see this is your first graph, and this will be the third segment. So for the same height, the run will be stretched. So it will be cutting the time axis. Here the gap was 5. Here the gap will be more than 5, surely. Now you can see the end limit. The end value of third segment is how much? 25, correct? So when t will be 25, let's see. See, never do something in a impulse that you will make a graph surely cutting the graph at 25. It will depend where it is cutting, okay? It is not necessary. It may cut at 25, but don't see that this is the endpoint, so the graph will cut here. You have to find what will be the value of x at 25. So x will be, I'm getting minus 2.5 into 25, correct? I'll get x is equal to minus 2.5 into 25 plus 62.5. Got it? So here you get what? Minus 62.5 plus 62.5. So in this case it is coming to be 0. So in this case it is cutting or meeting time axis. Here it is the time axis at 25 seconds. And this again I'm making a dark circle because this point is included. But it is not always necessary, as I told you. Okay, the graph will meet the horizontal axis at the end point. It may, if suppose at 25 you may get a value of something negative. In that case, the graph would be cutting the time axis before 25. So we have to check for the end point. So this will be the graph, and here you can see yourself. This is having more steepness and this is having less steepness. For the same height, there is a lesser run, there is a greater run. Got it? So these are the skills which we have seen how to make piecewise straight line graphs. Now you can do the related assignment, then you will get more command over the practice of these kind of problems in chapter 1. So we have seen how to plot the graph from the equations. Now in chapter 2 we will see the reverse process. If the graph is given, linear graph is given, maybe a single graph or maybe piecewise graphs, then how we can obtain the equations. So in chapter 1, what we are completing today, we learned a skill for plotting the graph from the equation. In chapter 2 we will do the reverse process. We will obtain the equations from the graph. Got it?